Import a tool library. In this video, we'll use import to load a tool library and modify tool order. In Fusion 360, we're going to carry on with our CAM milling setup, but it's important to note that the tool library is independent of the design. When we go into Manage Tool Library, you can see that in our document, in CAM milling setups and in setup 1, we currently have no data because we haven't used any tools yet. As soon as we begin creating tool paths, this will begin populating with data from our tool libraries. These can come from a local library, a cloud library, or from the Fusion 360 samples. Any of these are fine, but it's always important, again, that you match the data that you have on the shop floor. So we've already taken a look at importing a library into the cloud, but I'm going to repeat the process and import into the local library so that we can understand how to manipulate and create our own tool libraries. So we're going to right-click on Local and select Import Libraries. Once again, we want to find Practical CNC Tools and select Open. We're also going to go to our local folder and we're going to right-click and create a new library. This new library will be a new demo library, just something that we're creating as a placeholder. Anytime we have a new library or even an existing library in our local or our cloud folders, we can copy and paste tools into it or we can create them new. I'm going to go into my local practical CNC library and I'm going to begin filtering by milling, and I want to take a look for a specific tool. I'm going to take a look at bullnose end mills. You can see here that there are several different bullnose end mills. They're used for roughing, they're used for slotting, and we have some that are larger and some that are smaller. What I want to do is I want to take a look at the different ones that I have, and I want to bring some of them into my demo library. So as I go through each of these, we can take a look at the parameters and see if there's any difference between them. You'll note that we have 3 here with the same tool number. And as we go through, roughing with through tool coolant, roughing, and slotting. It's also important to note that all of them only have a single parameter for cutting data. If we want to add more data, we can use the Edit Presets option, which allows us to add additional cutting data. So for example, I can add another cutting data that says roughing with through tool coolant. So in this preset, I can change the coolant type to through tool and accept the changes. Now we have 2 different presets that we can use rather than having 2 different tools. Depending on the tool library that you're using, if there's one that's been around for quite a while, it might be important to try to condense it down using cutting data presets. So now that I know that this 3/16 bullnose mill has the preset for through tool coolant, I'm going to right click and I'm going to copy the tool and then I'm going to paste it into my new demo library. I'll go back to Practical CNC and I'll take a look at the tools 330. Once again, you'll notice that this one is roughing and there's a little bit more to the description. Roughing with through tool, roughing, and slotting. When we take a look at the differences here, we want to take a look at things like the cutting feed rate. It says 11.4 inches per minute, and when we go to the roughing, it's 22.8 inches per minute. So once again, we can modify these values to make sure that we're using the applicable spindle speed and the values that are needed to cut or to slot with this tool. So what we want to do is we want to create that default preset for slotting, which is based on 1140 RPM, and it has an 11.4 inches per minute cutting feed rate. So I'm going to right click and I'm going to edit this tool. I'm going to go to cutting data and I'm going to add another preset. I'm going to add one for slotting. And inside here, I want to modify these values. So this is going to be 1140. And when we do that, notice that surface speed automatically changes. There's a ramp spindle speed, which I'll also change. And then we're going to change the cutting feed rate to 11.4. Notice that it changes all the other values with the exception of the ramp feed rate. We're going to change this one as well. And then we have our vertical feed rate, which we're going to leave at 100 inches per minute. We're going to accept that change. And now we have a default preset for slotting. So once again, I'm going to right click and copy this tool, go to my new demo library, and I'm going to paste it. The reason that we're exploring this is because cutting data presets are extremely valuable, and it's important to take the time to set up your tool library before you get started to make sure that all the cutting data, the geometry, the holders, that all the information that's defining these tools is accurate at the start. It's not only important to make sure that we're putting the tool in the right position when we're cutting geometry, but it's also important for things like collision checking to make sure that the area of the non cutting portion of the tool or the holder are not colliding with stock. So make sure that you take the time to evaluate a tool library that you might have access to and that you make adjustments to those based on the actual tools you have on the shop floor. This is important not only for the tool numbers, but also the tool parameters and using the cutting data options in order to use a single tool with multiple presets. From here, we're going to close and we're not going to be using that local library, but it is important to just understand the functionality and flexibility we have when we're talking about importing and modifying a tool library. The last thing that I do want to note about our local demo library, and that is the option that we have to renumber our tools. Now, in some cases, you might want to keep the tools in the order from your tool library. However, if you're building a completely new tool library into a machine, oftentimes you want to reorder them based on specific geometry or cutting types. For example, you might want to put all your drill bits earlier on in the process. You might want to have your roughing tools before your finishing tools to minimize the amount of time it takes for your tool changes. So what we're going to do is we're going to take a look at using the options to renumber the tools inside of our new demo library. What we can do is we can select one of the tools and select renumber tool. We can choose what we want to start from and what we want to increment by. Right now it's going from 320 to 330. It's incrementing by 10 each time it makes a change in geometry. I want to keep that. However, I'm going to start this at a different number. Let's say that we were moving this to a different machine, and instead of 320, these bullnose mills were starting at 120. We're going to renumber both of these, and we can do this by selecting a single tool, or we can select all the tools in the library. If we select multiples and we say OK, you can see now that we've got 120 and 130, whereas in the original library, we were starting at 320 and going to 330. So once again, make sure that you understand the tools that you have available when you're creating your libraries. Once you have created a library, you can right click and export it to create an external version of this. And you can also share it based on your specific settings inside of your Fusion team. So make sure that if that's a requirement, that you do a little bit more investigation in the help file to better understand what functionality you have for sharing tool libraries between a team. For now, let's make sure that we close our library and we go ahead and move on.